Okay, so this problem is from section 7.4 of the textbook, and it's number 72, computing areas. So the problem says on the interval 0 to 2, the graphs of fx equals x squared over 3 and g of x equals x squared times 9 minus x squared to the negative 1/2 have similar shapes. A. Find the area of the region bounded by the graph of f and the x-axis on the interval 0 to 2. So the first thing that I did was plot a rough sketch of the graph f of x, and just do that by plugging in a few points. And so it wants that shaded region from 0 to 2, that area. So we have to integrate from 0 to 2. So as you can see, the area equals the integral of x squared over 3 from 0 to 2, and then we get x cubed over 9, and then just plug in the values and you get 8 over 9. So that's very simple. So that's A. Then for B, it asks to find the area of the region bounded by the graph of g and the x-axis on the interval 0 to 2. So it did say that the graphs have similar shapes. So there's g of x, and so we want to again integrate it from 0 to 2. So the first thing that we do is we bring the 9 minus x squared down to the denominator, and we put a root over it because that's what the negative 1 over 2 means. And then we here, in order to simplify this, we put x squared minus 9 plus 9, which is just the same thing as x squared because they cancel out, because we want to separate them into two expressions. So here we separate them into two expressions, so we have 9 over root 9 minus x squared plus x squared minus 9 over root 9 minus x squared dx. And then here, from here, what we want to do is we want to get rid of the denominator, so we multiply by the conjugate. So multiply the numerator and denominator by root minus 9 minus x squared, and as you can see, this as once you factor out the negative 1, you get 9 minus x squared on the top and the bottom, so that cancels to 1. So now you just have the integral of 9 over root 9 minus x squared minus root 9 minus x squared. So you have that denominator removed, and then you just take out the constant 9 and divide the integral into two parts. And then you will use trig substitution for the integral of root 9 minus x squared. So you use sine, so x equals 3 sine u, because 3 squared is 9, and u equals the sine inverse of x over 3, and consequently dx du is 3 cos u. So now you have the integral of 3 cos u times root 9 minus 9 sine squared u. So this is where you can use a trig identity. So 9 minus sine squared u equals 9 cos squared u, and that just comes from the sine squared plus cos squared equals 1, but instead of 1 it's just 9s now. So, and then you have 9 times the integral of cos squared u du. So here you can use the double angle identity, which is cos 2u equals 2 cos squared u minus 1, and cos squared u equals 1/2 cos 2u plus 1/2. So we just substitute that in. And so now to integrate cos 2u, because so when integrating cos 2u, you still have the 1/2 at the front, so you will substitute v equals 2u, dv du equals 2. So 1/2 times the integral of cos v dv, and of course the integral of cos is just sine, so you have 1/2 sine v, and then substitute back the 2u equals sine 2u over 2. And then for the 1, because remember we substituted that expression for 1/2 cos 2u plus 1. So the integral of 1 is u, and then times that by the 1/2, you get 1/2 u, and then times sine 2u over 2 by the 1/2 from up here, that equals sine 2u over 4. So then multiply all this by 9, because remember, if we go back over here, we did have a 9 on the outside, so we have 9 sine 2u over 4 plus 9u over 2, and remember u equals the inverse sine of x over 3, so we just substitute that in, and we get 3x root 1 minus x squared over 9 over 2 plus 9 sine inverse x over 3 over 2, and then we just plug in the values 2 and 0. So we end up getting 190.382, and so C asks for which region has the greater area, and the area under g of x from 0 to 2 has the greater area.